Hello, folks. Welcome to Rational Science. It's pretty cold over here in Germany. We got, I think, like 5 degrees below zero. And yeah, it's going to be a cold night. Anyways, we got a great day today. We're going to be doing a little bit of math. Not the math that you're thinking of. We're going to look at math in the context of physics. Does math have anything at all to do with physics? But before we get there, we're going to do a little bit of extinction, find out about some of the issues and questions that people made regarding subject matter related to extinction, such as genetic diversity and things of that nature. And I'm going to answer some questions, some comments that people made regarding the rope model. That's going to lead us into the subject matter, which is mathematics. Does mathematics have anything at all to do with science, let alone physics? Okay, let's get started with our extinction segment. Different subjects there that we cover. And here's the first one. First, there's an article that came out saying alien life in universe. Scientists say finding it is only a matter of time. And they talk about these planets that they've seen out there that are in the Goldilocks zone. And you can see there the picture I had in my website where I show that, if a planet is too far away from the sun or too close, it probably will not have life. It's got to be kind of like just right, and these people are talking about that, the fact that it's got to be in the Goldilocks zone. It's got to be maybe in the ecliptic, or maybe it's got to have a magnetic field. It's got to have an atmosphere, right? So and it's got to be a certain size. If it's too big, maybe it's got too much gravity. If it's too little, maybe it's got too little gravity for life to develop. Well, you have all these different parameters, and it's got to be kind of like just right. And so the issue is that finding a planet like that is like finding a needle in a haystack, and that's one issue. The other issue is that's, you can say, the space aspect of it. How about the time aspect of it? You got to get it just right. Life develops. It lasts a few million years, and then life disappears. And right now, we've been with life on Earth, maybe rounding off 500 million years. And that's kind of like a drop of water in the ocean, eternity. The universe has been around forever. And so 500 million years is nothing. And what do I mean by that? I mean that in order to see at least intelligent life like the level of humans, not only do we have to have all the Goldilocks conditions, but there's an added feature, and that is that they have to be at the same time as us. They have to be developing now, so that when we see them, we see them there. Obviously, there you got the velocity of light there, but what I'm saying, it's got to be within a certain range of time, because when we're gone, and that's what this channel's about, we're saying that we're going to be gone very soon. We only had maybe 200 years of magnetism, electricity, to develop the technology to be able to listen in or see, a planet that's got life in it of some kind, let alone intelligent life. But it's got to be within a certain window of time. They've got to be in the same 200 years. And what is 200 years? 200 years ain't nothing. There's nothing there. It's very little time from a universal point of view. Okay, so it's not only an issue of space, of distance, it's also an issue of time. Okay, fellow says, ask a question or says, extinction is the opposite of exist. Without location, you are extinct, correct? No, extinction is not the opposite of exist. Okay, exist is an object that has location. Extinction has to do with a species. You don't say that an individual human became extinct. We say he died, not that he became extinct. I mean, you can use poetry if you want there, but the issue is that extinction refers to species. And a species is not a thing. Okay, species is a concept. Talks about many individuals. Species are like talking about forest, a bunch of trees, or children, a bunch of kids. Okay, so species is not a thing. Okay, and so when we say a species went extinct, or an order, an entire order or family of species went extinct, what are we saying? We're saying that that you're talking about this species, or this group of species, is no longer around. Does that mean they don't exist? They didn't exist to begin with, because species is a concept. We can't talk in physics about concepts existing. Okay. Okay. So much for that one. I hope everybody can hear me fine. Let me know otherwise. I'm always worried about that. Sometimes, something happens with the video or the sound, and I keep ranting and don't realize it. Okay, so here's another fellow says, if all money disappeared, we would just create some new form of money. After all, that is what we have done in the past. How did mankind survive before we had commerce and money? Well, the problem is that today we depend on money to produce food. That's the issue. And we didn't need that in the days that we were hunter-gatherers. We didn't need money at all. So we didn't need it because money was not used as a medium of exchange to obtain food. Today it is a medium of exchange. If money disappears, we can't say, well, we're going to create another money. We're not going to replace brown money with green money, or vice versa. This is not an issue of changing money and saying, if money disappears, we just create a new one. It won't give us time to create a new one, because by that time, the whole planet goes to a standstill. You don't go to zero in green money and say, okay, now we're going to start with brown money. Money we can create. We can create all kinds of money. In fact, I think we've created the last kind of money, which is these bitcoins, right? What do you call it? Virtual coins, right? That's probably the last type of money we'll ever create, which is an internet money, which is more or less where the checking accounts also went. We used to do checks by paper. Now the checks are done through the internet. So there's relatively little, bills going around compared to the amount of money that is in total circulation. But the point here is, once that money disappears, what do we use it for? The only reason we use money is to buy food. There's no other reason. It's not that we use it to buy, houses and cars and all that, because that eventually gets translated again into food. The person who gets a salary, the person who runs a company, eventually need to pay for food for one more day in order to be alive one more day. So all we're doing with all these services and manufacturing, all the stuff that we create, is exchange it for food so we can live one more day. That's it. So we need money because of that, because without money we can't eat. Someone produces the food also because of money and distributes it because of money. Without money, the world doesn't run. I'm sorry to tell you. Okay, fellow says, along the same line, this fellow says, Bill should really stick to physics. His complete ignorance of biology is leading him to confusion. Economics has nothing to do with biology. One of his most bizarre premises is that humans are too inbred to survive when there are 8 billion souls on the planet. Even if the global agriculture system collapsed tomorrow, there would still be literally billions of humans all over the planet pumping up babies like there's no tomorrow. My, this fellow is so out of it. He doesn't know the first thing about anything. Sure, there could be a big population crash, but humans are going nowhere unless there's some truly devastating event for practical purposes destroys the earth. And he goes in there talking about the catastrophes. Everybody thinks of catastrophe. That's the only thing that can kill man. Some boulder from the outside, an asteroid, or a meteorite or whatever hits the Earth, or some volcanic activity, or maybe a supernova nearby just blows us off, the blows us out of the solar system. So all these people are talking about these things, about catastrophes. So the issue is, yeah, the global population will not. What did he say? How did he say? He says we'll be pumping out babies like there's no tomorrow. We're not doing it today. We're not pumping out babies. Okay, this fellow doesn't. He has no idea whatsoever what's going on out there. What we have out there, okay, is that we're not making babies anymore. Okay, I don't know if you noticed, but the population of Earth is dwindling. In other words, the growth rate is dwindling. We're approaching zero population growth, known as ZPG. Okay, and we've been doing that at least since 1963, the last time we had a decent rate. Since then, our rate has come down to 1, and we're going down to 0. Okay, that's the growth rate. And so, yeah, we're not pumping out babies. And the reason is very clear. We moved to the cities. We have high density. You cannot have babies in an apartment. You can't have 10 babies in an apartment, okay, like we used to in the farms. So we're not having babies. In fact, women don't want to have babies today, a lot of them, because they don't want to go through the animal aspect of it, you're putting out something between their legs, They think that's kind of animal behavior. And I think a lot of the women are really afraid to have babies because they realize they're going to be, first, they're going to be bloated for 9 months. It's like being sick for 9 months on purpose. And then they're going to have to go through the, pushing. Yeah. And, these are not the same women that we had in the old days. In the old days, women thought it was just natural and they would do it and they wanted to have families. That's changed completely, especially with the city women. And not to mention the men. Many of the men don't want to have babies either because they don't want the responsibility, or they see it as an anchor, as just more money that comes out of their pocket, etc. They want to enjoy life, and they say, hey, you're going to enjoy life probably better without a kid than with one. Not everybody agrees, but there are a lot of people who think that way. And so we're not having babies. So that's one issue. The other one is that, if agriculture comes down to 0, we're all dead. We need agriculture. But the problem is that in the old days, things would grow and we would just pick them. We were hunter-gatherers, right? At some point, we became more gatherers than hunters. And we can call that farming. We went into the farming era. But then we began trade at some point, probably in the Neolithic. We began to trade and say, look, I'm going to give you a chair for your corn. And we began to trade. First, the swapping. But today we depend on this thing called money. And again, we need the money to create this money to exchange and get food. Eventually, the whole issue is getting food. But what's the issue here? The issue is that money is what you give value to. Money has no intrinsic value. Money is just a paper or a number on a computer. That's all it is. And so they're giving you this thing and you're saying, oh, I'm going to take it. Well, why are you taking it? Well, because you give it value. And as long as we all believe in this religion called money, in God we trust, then we have money. Tomorrow we all lose faith in God, in money, and suddenly, money disappears. You have it in your hand, you have the dollar bill, or you have a number in a computer, but it's worthless because nobody will accept it, right? And it's like we all suddenly wake up, woke, and suddenly we realize that it has no intrinsic value. It was just a number in a computer. It was just a piece of paper with some ink on it. That's all it was. Or gold. Gold's a rock. You accept the rock and you say, okay, I'll accept that rock. Okay, today we accept it. But if no one accepts your rock again, from you to them, then you will not accept it from whoever tries to give it to you. So you got to think in those terms. Money is whatever's in your head. There is no such thing as money out there other than, the paper, the inked paper or the gold. But money is really the value you give to that thing because you know you can resell it, you can sell it to someone else or exchange it with someone else. That's the only reason we accept it. Okay, another fellow says, when you die, your soul changes location. Your soul changes location. Therefore, souls are physical objects. Oh, I see. Because he thinks that souls move. Therefore, it has location. It can move. Therefore, it's a physical object. That's his train of thought, right? Life is movement caused by the physical interaction between soul and body. And no, I hate to tell this fellow, but soul is thinking. It's conscience. It's mind. It's a concept. All those are concepts. In fact, it's worse than concept. It's a dynamic concept. Thinking is a verb. Okay? So, no, don't confuse it with a noun, which is what you think soul is. So there we have it. Objects that which moves. That's what he thinks it is. Change in location. And no, what is it? Soul does not have location. The mind, the brain has location, not the soul. The soul is created up there. Some think it's in the heart, but no, it's up here in your brain. Okay, objects that which has shape, and soul is not a noun; it's a verb. Okay, so it's in its brain that does the thinking. Okay, so yeah, some people still have these remnants of religion, of old time religion, traditional religions. And they believe in all these words that were created by our ignorant forefathers way back when, thousands of years ago. And we still believe, a lot of people still have these beliefs and these erroneous way of thinking. They think that, there are spirits out there, souls, and that they go to heaven, they move around and maybe move the curtain. Okay, fellow says, I disagree with picking sides because I told him the other day, you should pick sides in all these wars that are going on. And that's my recommendation to you. My experience, I got involved in a lot of that stuff. And what I got out of it is that never go into politics again. Don't get involved with politics. But fellow says, yeah, you should pick a side. If you are a mercenary from PNC Private Military Corporation, which are the future of war and have been like this since the 80s, I don't see why not. If you are skilled at violence and want to live dangerously, that's a good capitalist venture to make a lot of money from. It talks about this. Well, but that's not what I was referring to. I'm saying, we're not talking about a job and choosing sides because it's convenient for you. I'm saying don't you choose sides because you have your heart on the side of, for example, Hamas or Israel, or because you have your heart on the side of Ukraine or Russia. That's what I'm talking about. There's a good way to solve all the problems in the universe. On Earth, okay? All the wars, all the bad news you have out there, there's a very, very easy way to solve them all. And that is turn off your TV. And you'll solve all the problems in the world, believe me. Okay? And so that's what I'm referring to, not the fact that you go as a mercenary. Of course, if you go to a mercenary, it's not that you chose a side because of your heart. You chose it because of your pocket. Okay, and that's something else. It's not what I was referring to. Okay, another fellow says, I like this one. There are no gay animals whatsoever. These are just cases of mistaken identity. Okay, animals aren't very smart, and they often get confused by all these shapes they're looking at. That's why turtles will try to mate with shoes. Well, I can tell you, this fellow simply doesn't know. I mean, he doesn't realize what's out there. They've taken sheep, okay, male sheep, and they figured out that about 10% of them are homosexual. And the way they figure out that this is the case is they have a stall full of sheep, and one of them is a male, all the others are female. And remember, it's not only shape, it's smell. Okay, and so when the females are in heat, the males smell it. And all he sees is butts. And this guy will go in there, smell them, and he'll get to the guy and mount him. So, yeah, and you can see there the lion, he's having fun. No, it's not a mistaken identity. They are homosexual, okay? And the question is why? And I'm telling you why. They're homosexual because homosexuality, as well as autism that we see today, my argument is that it's got lots to do with genetic diversity. And we've lost our genetic diversity over the centuries because we've been inbreeding, and that leads to some of these problems, okay, that we see today, more today than in the past. But it happens with animals as well. You know, they've been inbreeding. Lions have been inbreeding for a long time. We've been forcing cows and sheep and all our domesticated animals, chickens and so on, to inbreed. And you know, we get the best stud, we want the best horse to run at the races, etc. So and not only with animals, we do it with plants as well. You know, grapes, we don't grow them with seed anymore. It's been a long time since I don't think anybody grows them with seed. You take a piece of a branch, you know, another, is it grapevine or whatever, and you take it and you plant it, and you have now a new grapevine, you know. So yeah, we inbreed all these things and doing what is called as artificial selection, and I don't think that's good for us in the long term. Okay, but fortunately, there's got to be no, or unfortunately, there's got to be no long term. We're due for extinction quite soon, and so I guess it doesn't matter anyways, you know. Okay, and final issue, a fellow says, if you abuse animals like Calhoun did, their brains will not develop normally. You can't release them into the well because the patterns in their brains will be all messed up. Well, the first thing I want to advise you is not to say what you said in the first sentence there, abuse animals, because that means you're talking about politics right off the bat, not science, okay? It means you got a gripe against Calhoun because he put these mice under, you know, very extreme conditions. Okay, so you don't have to get involved with that part of it. Now it says you can't release them into the wild because patterns in their brains will be all messed up. Yeah, no kidding. That was his experiment. His experiment was that, you know, something happened to the mice, and the question is how much of it had to do with nature, how much with nurture. Nature, very simple. You know, you had founder's effect. You have their great grandparents. I guess it was more than it was great grandparents, maybe, right? You know, they were normal mice. Normal meaning, you know, they were borrowed mice from some lab. Okay, they already had a lot of maybe their genetics was very similar. They should have done a genetic study before they borrowed the mice. But once they put the mice together, those were still normal mice because, you know, they were like from the wild. They still thought about hunting and mating and doing all these things. But all that disappeared, you know, with the next few generations, where we went from 8 mice, 4 couples, to 2,200 mice, all descended from those same 8 mice. And now you're talking about, you know, not only environment, you know, nurture, right? But you're talking about nature as well, because, you know, all those mice have the same DNA, same chromosomes or whatever, you know, coming from the original mice. And so the question is, how much of that played a part in these animals eventually, you know, going nuts? And yeah, they did go bad because, like Calhoun says, you know, they stopped being mice. It was so bad that he had to terminate. You know, it was just disgusting to see what was happening there, and he just terminated the experiment before it got to the extinction phase. But he ended up with, you know, fewer mice because, you know, the population dropped drastically. I think he ended up like 30 or 40 mice. You know, in fact, there's a study about the St. Matthew's Island, about the deer. And something similar happened there in the 50s and 60s where they left some deer on St. Matthew's Island And these deer multiplied, and they had nowhere to go because they were on this island. And eventually, when they went many years later, and they counted, there were lots of deer all over the place. Then they went another maybe 10 years later, and they only had like 25 deer on the island. You can look up the St. Matthew's Island issue. And there was only one male. He was kind of weak. He was kind of dying also. And 24 females. I mean, you would say that's paradise. No, not true. That was the end of those deer. It was the end of the deer. And so look it up. Okay, so let's move on to some of the questions people made, especially regarding the rope model. Okay, so they had some questions, some comments. Okay, so let's see what this is all about. Let's look at the questions. Well, it says an electron is bound to an atom, is one of the three primary types of particles within the atom. Bound to the atom. Bound how? What binds the electron to the atom? Why doesn't the atom, there you see the atom, planetary atom, which is the one that's still in use out there, why doesn't that electron fall to the nucleus? I mean, the nucleus is positive, right? Electron is negative, so you would think that, when it falls to the lower energy level, why doesn't it continue all the way to the center of the atom? That's the question for you. And the other issue is, why doesn't the electron spontaneously fly away? What's binding it? You're talking about bound. What's binding it? An electron rides a wave after being separated from an atom. Rides a wave, yeehaw. Like riding a horse. Separated from the atom. How do you separate it? I mean, what's pulling on it? Or is it the atom is pushing it out? I mean, what's coming in contact with the electron? That's what you got to explain. And you can't use a mathematical concept saying it's the field or it's the energy or it's the charge or whatever. No, you got to have a physical object. Okay, there's got to be a physical object there that is in touch with the electron, either pulling it out of the atom or pushing it out. Okay, and so scientists have filmed an electron in motion. Using a new technique that allow researchers to study the tiny particles' movement directly. Well, the first problem is the word tiny particle, and we'll get to that in a minute. But first, let's go with this one. Yeah, he got this information from, you can see there, I just Googled the, filming of the electron, and those were 4 of the articles that came out. And they say that what you're staring at there, that blue thingy, that's the electron that they filmed. They said they filmed the electron. So what's wrong with that? Why is this absolute poppycock? Okay, what they did there. Okay, well, let me show you why. Here's the article from one of those. It says, now it is possible to see a movie of an electron. The movie shows how an electron rides on a light wave after just having been pulled from the atom. Okay, so it's pulled. Okay, and says it rides on a wave, so that's where this fellow got that from. It says electron filmed for the first time ever. This is the first time an electron has ever been filmed, and the results are presented in the latest issue of Physical Review Letters. So here we have physics.org, right? They published the Physical Review Letters, and these people published this nonsense that they filmed an electron. A paper written by these Swedes from a Swedish university saying that they filmed the electron. Okay, so what's the problem with this? Why is this nonsense? Why is this poppycock? Total, absolute poppycock. Okay, well, let's find out. Here's one university, Texas A&M, the Aggies. The shape of an electron is never statically round like an orange. The reason for this is that an electron is not a solid little ball, which is how everybody always illustrates it, right? Electrons are quantum objects, and an electron is partly a wave and partly a particle. Yeah, I guess that's what they call a quantum particle. That means they have no idea what a what a particle is or what an electron is. Okay, it's partly half the time it's a wave, half the time it's a particle, I guess. Who knows what they mean by all that. I mean, it's either one or the other. To be more accurate, an electron is neither. Okay, that explains it even better. Okay, but is instead a quantized fluctuating probability wave function. Okay, so an electron is a number. Okay, that's what's going around the atom, a number. Okay, so that explains that, or a wave function, whatever that is. Yeah, it's a number. It's an equation. It's a number followed by a unit. That's the way the mathematicians see the electron. They don't see it as a ball. They don't deal with little balls. Okay, mathematics has no balls. Okay, an electron looks like a particle when it interacts with other objects. Okay, it looks like a particle. I thought you said you couldn't see it or whatever. Okay, when an electron looks more like a particle, it has no shape. Then how does it look? What are you staring at if it has no shape? What are you looking at? I like all these contradictions that they have in every sentence. According to the standard model, okay, physicists call an electron a point particle, meaning that it interacts as if it is entirely located at a single point in space and does not spread out to fill a three-dimensional volume. So it has no volume. Okay, it's a point light. Okay, it means it has no structure at all. In other words, 0D, zero-dimensional. If you find the concept of a fixed amount of mass being contained in the infinitely small volume, I thought he just said it has no volume, of a single point illogical, then you should. Yeah. But you have to realize that the electron is not literally a solid ball. Rather, an electron has no shape. Okay, so what is an electron? An electron is nothing. So far, these people have defined absolutely nothing. That's what zero volume, no shape, etc., etc. The 0D dimensions, all that means you're talking about absolutely nothing. So the electron is nothing. That's how it's defined. That's how it's described, right? So how can an electron go around or spin or do anything if it's not a physical object? It's not even a thing, according to all these people. Okay, so they have these contradictions. They never resolve them. Why? Because they're mathematicians. They don't care about structure. They don't care about balls. All they care about is units, numbers and units. That's all they care about. And so until you understand that, you're asking qualitative questions to a person who only deals with quantities, with amounts. And people don't always understand that. So here's from the Stack Exchange. Why can't an electron be observed? Can we physically see electrons? It says, according to the standard model, the electron has no extent, a radius of 0. Okay, as such a particle could never be observed, as it is not really there, but only indirectly observed by, for example, the effect of its electric field on other particles or objects. In other words, they're talking about a field, which is a concept, which is just a question of values surrounding ground zero, okay, usually decreasing in strength away from ground zero. And there's no such thing as this particle called an electron. There is no such thing as an electron, according to the mathematicians, not according to me. They're saying it's not an object, it's not a ball, it doesn't have shape, okay? And the only way they detect it is through this thingy they call a field, which is not a thingy because it's just a bunch of numbers followed by units. And they have all these numbers. They say, oh, the field did this and the field did that. The field cannot do anything because it's not a noun, not for the purposes of physics. In ordinary speech, you can call it a noun, not in science, not in physics. Okay, so no, field cannot do this or that. And if the field is generated by a nothingness called an electron, which is a point particle, elementary particle, fundamental particle, meaning one that is not made of smaller parts, meaning that it's just a point, meaning it's nothing, it's 0D, 0 radius, etc., 0 volume, then we're talking about absolutely nothing. That's what you see. Mathematicians deal constantly with absolute nothings. The photon is nothing. It's 0 mass, right? And no structure. Electron is no structure, no dimensions, no radius, no diameter, no volume, no shape. Singularity, black hole singularity, 0D, meaning it crushes all matter out of existence. Since matter is the mass is the quantity of matter, a measure of quantity of matter, then it has no mass. It's 0D, no shape. They deal with constantly with nothings because a mathematician doesn't care about things, about qualitative stuff. And it will be the subject of today, but keep that in mind, okay? Well, here's what Mr. Weinberg, he's died a couple years ago. He's a Nobel Prize winner. And says, what is an elementary particle? I would have to admit that no one really knows. Okay, that's very scientific of him. Okay, so nobody knows what an elementary particle is. Okay, why? Because they never define these terms. So they say fundamental or elementary particle, one that is not made of smaller parts, meaning it's the particle that makes everything else. But then that particle is defined as a point particle, zero-dimensional, and they start talking about the field and the energy and the charge. And they forget about the structure, the thing. And you can't do physics without things. And they never understood that you need to have a thing. You need to define what a thing is in physics, because without a thing, you have nothing. That's what you have. Okay, here's good old Mike Tyson. Is it Mike Tyson? No, it's good old this other Tyson, right? What's his name? Neil Tyson. Okay, so this is what he's got to say about it. Here goes. Listen carefully, okay? Well, don't listen. You got to read because he's just stating it. Okay, here it goes. Okay, so the electron has never been observed, and these people talk about the fact that they filmed the electron moving. What have they filmed? How can they? What they showed there, that little blue dot moving around. What is that? What have they filmed? And we can't say that they filmed an electron. Why? Because an electron is 0D. You can't film a 0D nothing. You can't film a singularity. You can't film that which has no shape. And people don't understand that. It just blows me away, that people have not figured out something as simple as that you need to have a shape, something with structure in front of you if you're going to film it, okay, let alone talk about it, because otherwise you're talking about a concept. Okay, fellow asked it here, moving on. Fellow says, the two threads of the electromagnetic rope and why they get together. Okay, that's an irrational question. Okay, and a lot of people understand this, but this fellow, I'm not sure he will. Probably doesn't have the intelligence, the gray matter to understand it. But why here is a purpose, reason type of question. So it's an irrational question because you're asking a question of philosophy and you're phrasing it as a question of physics. You're asking, really, this is what you're asking. You're asking, why did God, right, do this? Like, what was his purpose? What was his reason for doing this? That's what you're asking. That's not a question of physics. That's a question of philosophy, why someone does something, okay? So that's the context. And unless you understand that, well, what can I say? It says, why two ropes don't display the same behavior as the two threads? When are the ropes getting saggy and relaxed? And the answer is never. The rope is always taut, as you can see there. It's being under constant tension by the atoms. Why? Because every atom in the universe is essentially pulling on every atom in the universe. They're probably the whole thing, the whole universe is probably rotating. I'm sure it's not static, that everything maintains its place. I think there's got to be some kind of motion. Maybe there's a rotational motion, right, for the whole shebang. And it's a single thread, and this thread makes up every atom in the universe and the ropes that interconnect them. And so this whole thing, you can have to imagine it as a web of atoms and ropes that bind them. And when you say binding, you got to be careful because people think that it's attached. It's not really attached. It's that the thread turns into the atom, which turns into a rope, which turns into an atom, which turns into a rope, and so on down the line, from one end of the universe to the other. So it's one thread. It's not like anything is attached. Okay, so that's the first thing you have to understand. And then, the thread is pulled out, as you can see there on the bottom, when you have a magnetic field, so-called magnetic field. And that is that the whole line of merged electron shells, they release thread. And this thread rolls around the whole serpentine, as I call it, all the merged electron shells. And it swings all these threads around. So the thread does curve. The thread is flexible. The rope is not. The rope is always under tension. Okay, and that's just the assumption. We call it an assumption, and people don't know what an assumption is. Assumption is a supposition. It means you're gonna concede it in order to understand the theory founded upon it. And when you say, "Well, why is it like that?" Well, because God had a headache and he made it like that. That's the answer to that. You're asking a question of purpose and reason, not a question of physics. Okay, and so, I hope you understood. And here's another fellow says, you also presume matter is made of atoms. You just claim they are connected by ropes. Yeah, absolutely. It's known as making an assumption. It's the first step of the scientific method. And there you have the scientific method. Okay, step one, hypothesis. You present the objects, you point to them, and name them. Chair, table, tree, rock. Okay, you point and name. No problem. Definitions, you better have solid definitions. Hopefully very short definition. When they're very long, easier to tear apart. The more things you pitch in there. So make all your definitions very, very short. The shortest you can make them. Okay, and then you have what is known as the assumptions, the initial scene or the first frames of your film. You gotta describe the scene for your audience. You gotta say, look, this is my starting point. Okay, and that's known as an assumption, okay, or supposition, whatever. And that's why, it says you presume matter is made of atoms. Yeah, it's an assumption. You make an assumption that matter is made out of atoms. And then you say that it's connected by ropes. Yeah, exactly. That's the assumption. You know what an assumption is? It means you concede it in order to understand what the theory founded upon it. And the theory there, the explanation that you're going to give, which is a physical interpretation, you're going to talk about the causes and mechanism. Okay? That's essentially the scientific method. Okay? Because what people want to know or understand, how this universe works. How does gravity work? How does magnetism work? Well, if you're going to explain that qualitatively, right, then you're just going to have to give an assumption of some of the objects that you're going to be using, that you're going to be presenting to your audience, and the definitions you're going to use, the key definitions, not every word that you're going to be using in your presentation, and then you start talking and explain, the theory. That's the way it works. Okay, fellow says, for your rope model to be a real physical model, you also need a physical mechanism. And I guess this guy doesn't know what physical means. He just uses his word physical like if he knew what he was talking about. You need to answer what happens to those gazillions of threads. Okay, I don't know what happens. what's supposed to happen to them? They swing around when you have a magnetic field, for example. So yeah, I'm telling you what happens with them. But it says you've got all kinds of objects in the universe rotating or moving in all directions. How can the gazillions of threads not be affected or severed? Yeah, this guy is thinking about touch, and that's what gets them all. Everybody's thinking about see and touch. See, touch, see, touch. In this case, touch. They say, how is it that they don't get tangled? So he just rephrased it in a different way, but he's thinking about tangling. He says, you got all these threads, don't they get tangled? Or ropes or whatever, right? And so we start with the main point, and the main point that this guy did not get last time, he's not going to get it again this time for sure. An object is that not that which you can see or touch. Touch, don't use anything related to touch in your questions. If you use touch, it means you didn't understand the word object. Okay? The rope is an object because it has shape. Okay, so here you have it, my famous rope. Okay, does that have shape to you? Okay, do you see something there that has shape? Okay, so it has shape, but it does not have the ability to see, to be seen or touched. It doesn't have the ability to touch. Okay, and so to say how can all these gazillions of ropes, be out there and and they're crisscrossing, etc. You're thinking about touch. That's your question. Your question is touch. And the rope does not have the ability to touch. Very simple. And it's really not touching the atom. Okay, and let's make sure we understand that. The thread turns into the atom. It continues. There's no break. It's not like the rope is connected or bound like a separate object to the atom. The rope turns into the atom, which turns into a rope, which turns into an atom. Okay, so it's a single thread in the entire universe for all matter. Okay, so hopefully that sunk into somebody's brain. Okay, let's go with the next one. In fact, the final one, here it is. Fellow says, in physics, we say the ball crashed through the window. Okay, crash is a concept. Yeah. How does that differ from why was Billy sad? We have Billy, and Billy is an object. Well, there's the answer. Billy is not the subject, the issue in your first, in that second statement. The subject is sadness, okay? And sadness is a concept. So that's the subject of your presentation, okay? The why refers to sadness, not to Billy. Okay, you're in this case you're talking about the purpose of why the guy is sad. Okay, the reason, and not cause. Okay, the why is about purpose and reason. Okay, the actor in ball crash through the window is the object ball. It's the ball that's the object now. Okay, and the why is the cause mechanism of the crash. Okay, so you're talking about two different things. In one case you're talking about physics, and the other one you're talking about philosophy. Philosophy is, we define it here, okay? By the way, Stanford Encyclopedia of Philosophy does not define the word philosophy, so they have no idea what philosophy is. You will not find the definition in all planet Earth of the word philosophy. No one has any idea what philosophy is. Everybody informally thinks that philosophy is just a way of thinking. Okay? It says, oh, it's his way of thinking. It's his philosophy. But if that's the case, then everybody's a philosopher. We have 8 billion philosophers on Earth, okay? And you can't say that the Greeks, Aristotle and Plato were philosophers because you haven't defined philosophy. And here we define philosophy as anyone dealing with reasons and purpose. Psychologists and history, why Caesar went to England, etc., The whys, the reasons, the purposes, that's philosophy. So we separate those because you have science is about explaining. And in physics, we explain causes and mechanisms. And in philosophy, we explain reasons and purposes. Okay, that's why we define it that way. And so, yeah, once you have that, you can separate all these issues quite easily. This fellow's saying, why is sadness? Why does that fall under philosophy? Well, it falls under there because it's a purpose reason kind of question. Whereas why did the window break is a cause mechanism type issue. That's why that's physics. But then it's consistent because what is science? Rational explanations divided into physics, philosophy. One deals with causes and mechanisms, and the other one with purposes and reasons. Okay, let's move on to our math part of the lecture today. Okay, hope I'm still on. Okay. Wave to me otherwise. Okay, so why is math not the language of physics, which is the title of the presentation today? Okay, math is not the language of physics. And first of all, let's clarify that math is a language. Okay, so it's not a science. Math is not science. And science is about explaining. What did I just say? Science is rational explanations, and there's only two branches, main branches: physics and philosophy. Physics, causes and purposes, causes and mechanisms, and philosophy is purposes and reasons. Okay, that's what we explain. So philosophy is a branch of science, and so is physics. And you don't see math in there anywhere. And so does math fall under physics or under philosophy? Well, does Chinese, the language, does that fall under physics or under philosophy? Well, Chinese is a language. It's not a science. And same thing goes to math. Math has all these fancy symbols, and they represent relations. So math is not, it doesn't fall under physics or philosophy, because science is about explaining and mathematics only describes. It has no power to explain. And it describes using these symbols that represent relations. Okay, so math is not even a part of science, let alone out of physics, which is a branch of science. Okay, so let's hear it from the horse's mouth here. We have one fellow. His name is Matt O'Dowd, and he works for PBS. He's got a show called Space Time, and there he tries to peddle the mathematical physics side of what they call science, physics, okay? And what it is just a bunch of nonsense. Okay, here it is. Okay, he says, the following says, quantum fields have no subjective qualities and have questionable physicality. In other words, there's nothing physical about quantum fields. And people don't always understand that because they think field is a physical object. No, it's not. Okay, and he's telling you, it's got questionable physicality. Absolutely not. It has no physicality whatsoever. Physical means object, thing, and fields are not things. Okay, field is a noun only for the purposes of ordinary speech, not of science. And he continues, says, they seem to be completely describable by only numbers. Right, because it's describe and it's only numbers. What are numbers? Verbs. Number is the verb to count. Okay, so yeah, all they can do is describe, and they're using these numbers to describe them. And their behavior precisely defined by equations. What's an equation? Again, it's a concept. Okay, it's a relation. That's all it is. Okay. In a sense, the quantum world is made of math. I love that. Yeah, because the quantum world might be made of math, but nothing in physics is made of math. Nothing in science is made of math. Okay, and so let's distinguish math from science. So does that mean the universe is made of math too? Okay, I hope I'm still on. I'm worried that maybe I get cut off here. Okay, it says, so does that mean the universe is made of math too? Only because what? Because the quantum world is made of math, and general relativity is made of math, and string theory is made of math. Okay, if you believe the mathematical universe hypothesis, then yes, and so are you. So you're made of math. Okay, I thought you were made of atoms. I thought you were made of cells, molecules, and it turns out you're made of math. That's the way they look at it. Why? Because that's the only thing that's of interest to a mathematician. They call it physics, And what they're talking about is math. So where did Matt O'Dowd get all this stuff from? And we can trace it to this fellow named Mark Tegmark. He came up with this notion. It's a chart, essentially. And what is it? He's saying that, just an example here. He says you have a culture, okay? You have people out there who socialize, etc. And you can say that's sociology, okay? And where does that come from? Well, it comes from the mind, people thinking, okay? And so they end up with this culture. But where does the mind come from? Where does all this thinking, or what is the substrate for it? Well, it's the brain, okay? The brain is what essentially, causes mind to happen, okay? All these fields that are in there, all this magnetic fields, maybe some chemical reactions, right? And what is the brain? The brain is cells, and you can say that's biology. What are cells? Well, they're made out of molecules. You can say that's chemistry. And what are molecules made of? Well, they're made of atoms. And so we go down the line, and what Mark Tegmark suggests is that eventually you end up with more and more quantitative math stuff, and you started off with qualitative, language stuff, So you go from more language to this world of math, and you end up with what they hope, what their holy grail, which is this theory of everything, which is the mathematical universe. Okay, so that's why they say that everything is made out of math, including you. Okay, so that's in a nutshell what these people are thinking. They say that physics is all about math because we're getting down into this rabbit hole, right, where it's ever more quantitative, right? But that's because they took it down there. It's the mathematicians who took it down to math, that say that science is all about math, physics is all about math. It's them. It's not that anybody else. I mean, the Greeks, they thought they wanted to answer the question of, how does this universe work in a qualitative way? And that was lost in the 17th century, okay, when they did the so-called 17th century revolution, right? Okay, so here's this fellow. His name is Leo Susskind, and I think Susskind or Susskind. Anyways, he's from Stanford, so-called physicist, actually mathematical physicist. And what does he say? Well, he says that you and I evolved in a world of 3 dimensions. We can't visualize more dimensions. I can visualize 3 dimensions in my head, but I use X, Y, and Z to describe them mathematically. Now I go to 4 dimensions or 5 dimensions. I can't visualize them anymore. I can't say now, close your eyes and view in your head 5 dimensions, because I can't do it either. So we're stuck needing mathematics because evolution didn't equip us to be able to visualize quantum mechanics. Okay? It didn't equip us to visualize 11-dimensional space-times. Evolution did this to us. So yeah, these people are talking about math, and they're trying to visualize something which is qualitative, like anything that is 3-dimensional, and that's qualitative. That has to do with physics, right? If it's got 3 dimensions, hopefully it's an object, it's a thing, and they don't realize it. They want to quantify it. They want to talk about numbers. That's the whole issue. And so the question is, what are these people talking about? Are they talking about math, or are they talking about physics? Okay, so which is it? And here we have another Nobel Prize winner. I talked about him a little while ago, and here it is. He's Steven Weinberg. He died a couple years ago. Says, I don't think mathematics can ever be regarded as an explanation in itself for anything. And this has not always been well understood. And why isn't he straightforward? Why is he, piddling around, saying, well, I don't think it can be, maybe, perhaps. No. It's very straightforward. Mathematics cannot explain anything. Mathematics is not an explanatory language. Only describes and has no power at all to explain. And people don't understand that, including him. Okay? So yeah, the issue is that Math does not explain anything. That's why we have no explanation. When they give you an explanation, the mathematicians, they give you a bogus explanation. They say, well, space is warped and time is warped and Big Bang happened, creationism. And they give you all this nonsense, black hole singularity, there's nothing there, but it swallows everything in because it's got infinite mass and who knows what else. And when you call their bluff and you say what you just said is nonsense, the guy says, well, that's not important anyways because that's not in our line of business. It's not in our line of work. We don't do that. So the question is, why did you try to do it anyways if it's not in your line of work? If you're not an expert in this stuff, why did you attempt to do this? I mean, it would have been much easier just to keep your mouth shut and say, I'm going to do math. Okay, fine, do math. But don't tell me that you're going to climb over the fence and tell me how physics works. You have no authority to do so. Okay, so here's one fellow that tells us clearly. Okay, he says, Donald Simonek, a university professor in Pennsylvania, science doesn't explain, science describes. Why does he say that? Well, because math only describes and they equate physics, meaning science, right, with math. That's the whole issue. Okay, so yeah, if this is your starting point, if you already made up your mind that physics or science, which they kind of equate each other, right? They say, is only numbers, is only math, and yeah, then your conclusion is that science or physics only describes. And here we have a site, says Encyclopedia Britannica, says, during the 16th and 17th century, scientific thought underwent a revolution. A new view of nature emerged, replacing the Greek view that had dominated science for almost 2,000 years. Okay? Yeah, so what they're talking about really is the Greeks, okay? And this lasted for all this time, okay? And 2,000 years at least, you would say. And what happened? Give me a second here. So this lasted 2,000 years. Why? Because everybody just followed the Greeks. Whatever the Greeks thought was right, meaning Aristotle, people just memorized that and just repeated it. Okay? And so what happened? What happened was that in the 17th century, things changed. Science became an autonomous discipline distinct from both philosophy and technology, and it came to be regarded as having utilitarian goals. Okay, by the end of this period, it may not be too much to say that science had replaced Christianity as the focal point of European civilization. Out of the ferment of the Renaissance and Reformation, there arose a new view of science, bringing about the following transformations: the re-education of common sense in favor of abstract reasoning. Well, yeah, I think they lost common sense and they just went into abstract reasoning, especially when they got into the 20th century and started doing quantum mechanics and general relativity. It was abstract reasoning, but they forget to say that it's irrational abstract reasoning. The substitution of a quantitative for a qualitative view of nature. Exactly. They replaced explanations with descriptions, with mathematical descriptions. The view of nature as a machine rather than as an organism. The development of an experimental method that sought definite answers to certain limited questions couched in the framework of specific theories. The acceptance of new criteria for explanation, not really, because they haven't had any explanation whatsoever, or you could say the new criteria was irrational explanations, and they accepted those, stressing the how rather than the why. The how meaning description rather than the why meaning explanation. That's what happened. Math can only describe. That had characterized the Aristotelian search for final causes. Okay, so that's what happened in the 17th century. Oh my God. There I go. I'm back. Okay, so what was it? The issue was that they went into mathematics descriptions. Why? Because they started doing experiments and they said, look what Plato and Aristotle were doing. That's not good enough for us. What we are doing now is doing experiments, and through experiments, we're going to get some objective data. What was the objective data? The objective data was measurement. They would measure something, weigh it or whatever, or distance or time. And once they got that measurement, right, they turned it into some kind of equation, into numbers. That's how we went. So it was experiment, math, experiment, math, experiment, math. That's what happened starting in the 17th century. And they forgot all about the purpose of physics to begin with, which was defined, by the way, by Aristotle. Okay, purpose of physics, what is it? To explain how this universe works. They forgot all about that. They say, who was it? Richard Feynman, he said, we've abandoned all that stuff. We don't explain anymore. All we do is math and descriptions, because that's objective, they say. Whereas explanations, that's opinion, and so we gave it to the philosophers. That's what happened here. Okay, that was the revolution that really happened. And unless you're in tune with that, you don't really know what's going on in the world today. Okay, here we have good old Toth there, and he defines each one of these. This is out of the Wikipedia. Mathematics is an area of knowledge that includes the topics of numbers, formulas, and related structures. Structures, I like the fact that they use the word structure. It's so misleading because it suggests that they're talking about objects when they are not. Shapes and the spaces in which they are contained. Now, math doesn't deal with shape at all. Okay, and quantities and their changes. Yeah, quantities and changes. Yeah. There is no general consensus among the mathematicians about a common definition for their academic discipline. Yeah, it's not an academic discipline. Maybe that's why the mathematicians are all, in disagreement. It's a language. It's just a language. Has nothing to do with a discipline, meaning science. What is physics? The natural science of matter involving the study of matter. Okay, yeah, we don't study in physics, in science. What we do is explain, not study. Anybody can study without explaining anything. Okay, and its fundamental constituents, its motion and behavior through space and time, and the related entities of what? Energy and force. So what are they talking about? They're talking about space, meaning they think of space as 3D. What they really mean is they're going to put a set of coordinates, meaning not coordinates or dimensions. They're talking about number lines. So space, they think of number lines. Time, another number line. What's energy? A concept, dynamic, mathematical concept. What's force? Dynamic, mathematical concept. So no, physics doesn't deal with any of these. It deals with space only because it's the background to objects. Otherwise, it doesn't deal with time, energy, or force. These are concepts, mathematical concepts, and physics doesn't deal with that at all. Mathematical physics, what is that then? We got math and we got physics. Now we put them together and we get this mathematical physics. Refers to the development of mathematical methods for application to problems in physics. Problems meaning equations, meaning numbers, meaning units. That's what they're talking about. They're talking about doing, solving problems, mathematical problems. That's what they're talking about. They're not talking about physics. They're talking about describing mathematically and solving problems. What are problems? Relations. So you're trying to solve from a numerical point of view, quantitative point of view, something about these relations. That's all it is. Okay, so we call this, us here at this place, this channel, we call it the mathematical method. Why? Because this is what we've inherited from the 17th century. And what is it? It's a method of research and persuasion. They're talking about convincing you, persuading you to believe something that is true. They say, we're going to prove things to you, meaning we're going to try to twist your arm until you convert and we recruit you to our congregation. That's what it's all about. So they start with observation. Well, observation, to observe, what is that? They just said a minute ago, I said, you can't observe the electron. I didn't say it. Other people said it, that you can't observe an electron. Why? Because it's zero-dimensional, defined as such. It's an elementary fundamental particle. There's nothing there. It's 0D, zero radius, no shape. What are you talking about? You're talking about nothing. That's what you're talking about. So how can you observe nothing? What do you mean by observe? You know? And besides, even if that were the case in science, we do not observe. We do not gawk. You know, that's the issue. Explain tentatively, which they never do because the explanation is always bogus. Okay, what they really talking about, they call it a hypothesis. It's not. Explanation is a theory. Okay, predict. We don't do prediction. No astrologers, no palm readers in science. So I don't know what this predict is about. Obviously, they're talking about math. They say, if the lion is running at 40 miles per hour, it's going to catch the deer. Why? Because in so many seconds, it's going to be at such and such place if it runs in a straight line. So they can predict things, and they say, I can predict if the lion's going to catch it. That's what they're talking about. What's that got to do with science? Experiment. They do a lot of experiments, and they get equations out of that, measurement and equation, right? They describe mathematically, again, equation. Invent technology to confirm the theory because they think that technology is proof of the theory. They say GPS confirms general relativity and computers prove quantum mechanics. What's that? Technology confirming physics or their equations or, their theories, right? That's the way they look at it. They convince other mathematicians, other colleagues, right? Called proof, truth, fact, knowledge. Those are the words they use. They verify the measurement, what is called falsification. Someone else verifies your measurement. If they verify it, you win a prize, maybe the Nobel Prize, and you walk the celebrity circuit. Now you have authority to trash anyone on earth because you have this gold medal in your hand. Right. So that's called science, according to these people. Okay, fine. So how do we compare it against ours? This is a rational scientific method. We call it the rational science. It's really the scientific method that we should have always had. Okay, we start with a hypothesis. Okay, and we have the object's definitions, the initial scene. Okay, and then we have the theory, the mechanisms and causes that are founded upon that. Okay, so that's more or less how this works. Okay. And I hope I'm still on. Okay. Give me a second here. And let's remove this. Okay, so you can see the difference between the mathematical method and the scientific method. Okay, so where does this take us? Well, we're just going to give an example here today. We have gravity, right? Everybody knows about gravity, I think. And we've probably known gravity for as long as we've been around. Here's the only experiment you ever need to do in science, in physics, right? For gravity, you let go of the pencil and it falls to the floor. Always falls downwards, never upwards. It always falls to the floor, never to the ceiling. Always to the ground, never to the sky. Okay, so there we have it. Now we have to explain it. Okay, do we need a number to explain that? Do we need to know how fast it went? Absolutely not. It's a qualitative question. And then the question is that a question of physics? Is that a question of science? And a lot of people out there, especially the mathematicians, will say, no, that's not. That's not what we do. We do equations. We do measurements. We do units, numbers. That's what we do. But it turns out that people ask these questions. You go to Quora, right, which is a question and answer site, and people ask these questions, say, how does gravity work? How does magnetism work? What is electricity, etc.? Who are the people who answer these questions? Well, most of them are physicists, or they sign as physicists. Or they're students of physics, or PhDs, or getting they're graduating in physics. They're all into physics. Well, so it appears that this question belongs to physics because so many physicists attempt to answer it. And yet when you corner these guys and put them against the wall and say, call their bluff and say, hey, you're saying that you are physicists. Okay, answer the question. What is gravity? And they say, well, it's warp space or warp time. Warp time? That sounds like nonsense. Yeah, it is, but we don't care because it's not in our line of business. The philosophers do that because that's opinion. So why did these people attempt to do that if it's not in their job description? That's the question. Okay, so we got a problem here because these people are answering the question. They're giving you their peace of mind. They're saying, I can tell you what gravity is. Oh, what is it? Well, it's warp time. And you say, that's irrational. Yeah, we know, and we don't care because it's not in our line of business. So we go around in circles with these people. If they have nothing to do with physical interpretations, why did they even attempt to give a physical interpretation to a question of physics? If they're going to do math, stay in the realm of math. Don't jump the fence into physics. That's the issue today, really. Okay, so here we have what is gravity? This is how general relativity or mathematical physics in general answers. Says it's warp time. You know, those lines that you see there, white lines, all those lines, those are coordinates, what they call coordinates. Those are really number lines. And they have these number lines, which is a mathematical concept. As you can see, they're warped because there's a depression there caused by the Earth. And the moon has no other choice but to roll around the Earth because this has this wall of time, of curved time, that does not allow it to leave the solar system. That's the explanation. And again, when you tell them this to say, hey, that's an irrational explanation, they say, well, you know, we don't care about that because that's not, you know, our job, in our job description. It's not, you know, our line of work. So why did they attempt it? Why did they do that? Why do they give you a bogus explanation and then tell you that, yeah, they don't understand it either, and it doesn't matter anyways because it's not part of physics, because physics is just math. That's a whole argument there. Okay, and so they even throw in and laugh at you. They say, people pay attention to warp space, to the warp canvas. So this fellow says, teacher, right, says, understanding gravity, space-time is like a rubber sheet. Massive objects distort the sheet, and wait, they distort it because they're pulled down by what? And the teacher said, oh my God, space-time is like this set of equations for which any analogy must be an approximation. No, it's not an approximation because approximation has nothing to do with the question that we're asking. We're saying, what is gravity? This guy tells us that it's a rubber sheet. And then they say, don't take the analogy so literally. And no, it's when they make fun of you by putting this cartoon in there, they say that the student says, oh, that's so boring. No, it's called irrational, not boring. Okay, so use the correct word. That's irrational, what they're saying. When they say it's not in our line of business, then you say, why did you attempt to give me this bogus explanation for how gravity works? That's the bottom line. Okay, so let's go with an example here, just to put it in the right context. What is the problem here? What's a qualitative problem? They say, we don't know what gravity is. You'll find this in core also. A lot of the people who answer said, we have no idea what gravity is. We're still researching. Someday we'll figure it out. Okay, so this is the party line. This is what they tell you. This is what they say. Fine. Okay. Let's give an example here. Okay. Here we have good old Casimir, my good old buddy there, and he's pulling on a donkey. Okay. And so we say, okay, you're there with your wife or your girlfriend. Okay. And you say, well, how did this happen? Okay. And how did the donkey go from A to B? Okay. And so person says, or your wife or whoever's next door to you says, well, very simple. Here we have this fellow, this farmer, and he's pulling on a rope, and which is tied to the neck of the donkey, and the donkey is pulled forward. It's straightforward. I mean, just by watching this, you can understand, right? In this case, right, why the donkey's moving from A to B. Because being pulled by a rope. everything is visible there. The farmer, the donkey, and the rope, everything. So it's so easy. There's no mystery here. Okay. So what's the issue? The issue is here you have the general relativity version or mathematical physics version. They say the reason they came together is because they slide on a ball, because you have this warped space-time in the vicinity, right? Warp time, and so that's why they fall towards each other. And of course, nobody knows why they fall downwards. Why don't they fall upwards in the bowl? But that's never answered. They say things always come down. Fine, okay. So what's the issue? The issue really with the whole issue here is the following. What if we make a change in our scenario? Instead of having the farmer with a rope tied around the donkey's neck and pulling on it, right? We're going to have the farmer just going like this because you can't see the rope. The rope is invisible, or you can't see it because you're too far or whatever. You don't see the rope. All you see the farmer going like this and the donkey coming towards you. And here, let me illustrate that. Here it is. Okay, you see that. And now the question, now you ask your wife or your girlfriend, you say, well, how did that happen? How is it that the donkey is coming towards the farmer? And you say, well, I don't know. I have no idea. And if you compare them, the only difference between these two, right, here is the other one, is that you can see the rope here and you cannot see it here. So the only issue here is that in one case you can see the rope and in the other you cannot. And so the question here is that maybe there is a rope there. It's just a question that you can't see it for whatever reason. Maybe you're too far. Maybe your eyesight is not good. You don't have 20/20 vision. Maybe it has a color that blends in with the background. Maybe you got the sky there in the background, blue sky, and you have a blue rope. I don't know. And so you can't see the rope. And just because you can't see the rope, suddenly, it's an unsolvable problem. Here you can see the rope, and here you cannot see the rope. And the only difference there was, seeing, subjectivity, not what is there. Because what is there, if there is a rope there, it's just that you cannot see it. Objectively, what's coming out of the scene is that there is a rope, okay? Subjectively, you understanding or visualizing or touching or whatever, you cannot, see the rope. Okay, so the issue is that. And here we have the same issue with a pencil. If I could show you all the particles that are pushing it, or all the ropes, in our case, that are pulling it, then you would say, that's no big deal. I understand that. That's kid stuff. The ropes are pulling. Why? Because every atom of the pencil is tied to every atom of the earth. So the closer it gets, the wider they go. You understand the mechanism. But only because I made the ropes visible for you. But if you cannot see the ropes and you cannot touch them, you cannot see the particles that are pushing, if that's your theory, right? Because of that, you say, well, I don't understand how that's done, how Mother Nature does this magic trick. Only because you can't see it. And what's the problem there? Well, the problem there regarding our subject matter today is that math doesn't deal with object, with things. So math is not in the business of looking for the mediators, the physical mediators. That's the whole issue. See, so math, the mathematicians, they call themselves physicists, but they don't do physics because physics starts with objects. You need to have an object. And these people don't start at objects. They start at new numbers, quantities, measurement, experiments, right? Predictions, observation, and they're not doing what they're supposed to do, which is look at the objects, the mediators. And hopefully, this magic trick, right? The pencil falling, hopefully, the pencil is being touched by something. It's either touched by something that pulls it or it's something that pushes it. But hopefully something is coming in contact with a pencil, because otherwise you're doing action at a distance. And action at a distance is black magic. It's witchcraft. That's what it's called. It's the action at a distance is the scientific term for witchcraft, okay? That's what mathematicians do. They do action at a distance because they don't care about the physical interpretation, and then they just look at quantities and saying, this is how fast this thing is coming. This is how much mass it has. This is what the distance was. This is how much time it took. They're looking at all these parameters which they measure, and they try to give you an equation to describe what's happening, but they cannot explain because they're not in the business of explaining, and they never will, and therefore they'll never figure out what gravity is. Because gravity, if we want to know how this universe runs, we need to look at qualitative stuff, and those are the questions people ask. They want to know how gravity works, meaning why, what causes it to work the way it does work. And those are the questions you'll see in places like Quora. They're all answered by physicists. The physicist says, this is what it is. It's all irrational. They say, well, we know it's irrational. We don't understand it either. And anyways, it's not in our job description. It's not in our line of work. Then why in the world did you attempt to give me a bogus answer? We'll see you next week. Bye-bye.